Now I see your files with Python sites. Now it's up.
Ah, okay. And so down the bottom I have pattern 3 again, so you can just say what would I have to add on to it.
Okay. Right. Oh no, be back just a minute. Molly! I'm only keeping the dog outside because she's gonna scratch me. Come on. Come on. Stay here, like. Stay here. Alright, what one am I doing?
Part A. So what's basically the next one in the pattern? How would you do it?
Okay. Oh, 16.
Okay, so what, this one has 7?
Yeah, 7, 10, 13.
10, 13, and yeah, so it's just 3 more, and it looks like it's 1 at the top, 1 at the bottom, and then 1 in the middle, like that. Okay, and then how would you get how many dots are in pattern 15?
Okay.
Or maybe we'll come back to that. Maybe we'll come back to this, because there's a much easier way to do it. Okay, how would you draw the next pattern?
How would I draw it?
Yeah.
Oh,
And I've copied pattern 3 down the bottom. So what would you have to like add on or whatever?
$28, I think.
Okay, and how would you draw it?
Like number 3, but with another one on the end, pretty much.
Yeah, so even if you didn't know how many sticks, so I might even skip ahead because you're using a good method for the later ones. Yeah, so this is a good one. Okay, so draw pattern 4 and then fill in the table.
Pattern 4 would have another triangle on the end, and then
Yeah.
nine, and then 11.
That's it. How could you get pattern 15, do you know? How many sticks are in pattern 15?
I'm not sure. Wouldn't you just add it up?
Well, keep going with the table. So the next one, it says pattern 50, so that might not work in the long term. What is the connection, can you see, between the pattern number and the number of sticks in it? Like, what would you have to do to the pattern number to get the number of sticks?
There's 2. Oh, so would it be 17?
How did you get that?
Because I saw 1, and then it goes from 3, and 2, and then 5. So there's a 2 difference.
Right.
And then I got 15 and added 2 onto it.
So because of proportion, that method won't work. What do you have to do to go from 1 to 3, 2 to 5, 3 to 7? what function or what operations would bring you from the top one to the bottom one, top number to bottom number?
So you say that again?
So like, what would you have to do to the top number to turn it into the bottom number each time?
Add.
So the amount you're adding is increasing, so just adding won't be enough.
Add one up from that number every time.
So we can't do that for something like pattern 50. We don't know what that would be. Is there any other way? And you can use 2 operations.
Hold on, would it be 16 and 15?
Yeah. Do you mean 31? So basically, if you double the top number, then add 1, you get the bottom number. So double 3, you get 6, then add 1, 7. Double 4, you get 8, add 1, you get 9, and so on.
Oh, okay.
And so that's like a connection between them. And so how can you use that to get how many are in pattern 15?
Double it and add 1 onto it.
And what do you get?
31.
And part D.
Oh, she can use the method we just used.
Yeah.
So 101 sticks.
Well done. And what method? It says write down what method she can use.
Double it and add 1.
Yeah. So double the pattern number and then add 1. Pattern number and add 1. So this is the beginning of kind of the algebra of it. You know how x is for an unknown number? You can, when you have a known counting number like this, we call it n. So all these patterns always start with 1, and they go up in ones. So pattern 1, pattern 2, pattern 3, pattern 4, pattern 5. In general, we say pattern n. We don't say pattern x because it's just, we know exactly what these numbers are. They just start with 1 and you plus 1 each time. So basically, in general, you have n. If you double it, what do you get?
And 2.
Yeah, or 2n usually, right? And then you add 1, and so you get 2n plus 1. And so the formula for finding any term of this pattern is 2n plus 1. And so 2 times 50 plus 1, 2 times 15 plus 1, and so on. So I think that might help, but we'll do that a bit more later. Okay, let's try this one.
Pattern 4, you would just add pattern number 1 on the end of it.
Yeah, that's a good way of looking at it. Okay. And the reason why I have like part A, B, C, and D is because it really helps. Like doing part A really helps you with part B really helps you with part C, and so on. Okay, next one, part B.
20 white squares.
Well done. Part C.
$15 grey squares.
Well done. And how did you find your answer?
For the first one, I just...
No, for C. C.
Kind of guessed that, but I knew it was either 15 or 25 because how many grey squares you have, you double the white ones.
Right.
And there's a 5, so
I would say, so basically, yeah, for every one grey, there's 2 white. So in total, that's 3 squares.
mm,
Like they're in a row of 3 each time. And so you can just do 45 divided by 3.
mhm.
Yeah, and so that would tell you if it has 45 squares in total, then it has 15. Oh, how many grey squares? How many grey squares? Yeah, a third of the squares are grey. Yeah, so you just divide it by 3. That's it. That's it. Okay, let's try this one. Can you see this one?
6 stars.
Yep, I think so. Yeah. Okay, how about this one?
11 for question B.
Yeah. Any idea about this one?
14 for C.
14. Nope. So now what's really going to help is if we make a table. So let's say n for pattern number. Let's say stars, triangles, and what was the last one? Okay. And so you can find connections between them. So the difference is instead of just 2 things is now 3 things. So n in general, 1, 2, 3, 4, like pattern number. And that one went up to 5. And I'll just say ... 10. Okay, so pattern. So this was the stars. And then the triangles started with 1, 2, 3, 5, 7, 9. An idea. Can you find a connection? What is the connection between n and the stars? The pattern number and the number of stars.
For every 1 star, 2 more triangles appear.
So just the connection between n and star, pattern number and stars.
Goes up in 1 each time.
And so how many stars would be in pattern 10?
10.
No. The pattern number.
12.
No. What's the connection between the pattern number and the number of stars?
It goes up in 1.
So you're looking at it across. Look at it going down. What's the connection between the pattern number and the number of stars?
For number 1, there's 2 stars.
Right, so you've got like 1 and 2, 2 and 3, 3 and 4, 4 and 5. So what's the connection between n and the number of stars? What do you have to do to n to get the number of stars?
You have to add 1
Yeah.
or
And so
yeah.
how many stars would be in pattern 10?
11.
Yeah. So now we need to find a connection. Can we find a connection between the pattern number and the triangles?
Mm-hmm.
So what would you have to do to the pattern number to get the number triangles?
I'm not quite sure.
Maybe I need to do some different thing that will make this easier. Maybe I'll just kind of skip ahead to something. I think it'll make it easier. Okay, let's try these. Next term of the sequence. So now they're not even using pictures anymore, they're just using the numbers.
Alright, next term. 21.
That's it. How about this one on the right?
See?
19, did you say? Yeah. Okay. How about part B?
Part B. Hold on. 50,000 something. I didn't see that bit.
Yeah.
Would it be what, 203?
Well done. And part C.
Oh.
Sorry?
Could it be? I'm not sure.
What do all the numbers in the sequence have in common?
No. Reveal prime numbers.
Simpler than that. I'm not sure. So up here, they're all odd numbers. So why is this number not in the sequence?
Because it's even.
Yeah. 372 is even. And all the numbers in the sequence are odd. Odd. Let me switch over to something else. Yeah, this one. Okay, how about this one?
No, it's not.
Why not?
Because I'm not that sure.
So, if you keep going with this sequence, would one of the later numbers be 150 or not?
No, because No, because if you keep on adding 6 to it, it won't. Nah, it won't.
Why not?
Um, because if you, I'm not quite sure, to be honest.
What do all the numbers in the sequence have in common?
They'll prime. No,
Simpler than that.
they're all even.
They're not even.
Odd.
They're all odd. Yeah. And okay, go on.
Because 157 is not an odd number.
Yeah. These are all odd. 150 is even. Yeah, so the numbers in sequence will always be odd, and 150 is even. Okay, how about this one?
Because all numbers are even, and that's an odd one.
Say it again, sorry?
All of them odd numbers, and that's even.
No.
Is it? Are they all even, and that's odd?
So this is odd, but 7 is also odd. 17 is also odd. So there's a mix of odd and even numbers in the sequence.
Is it prime numbers?
No, it's simpler than that.
Simpler.
Yeah. So just by looking at it, why will this number never come up in the sequence?
Because it goes up in. Is it because it goes up in fives and.
Right?
Is it because it goes up in fives and it won't end up in that sequence?
Why won't it end up in the sequence?
So if you keep on adding 5 on to 2, you're not going to get a 1.
Correct. Because all the numbers in the sequence end in 2 or 7. And 271 ends in 1. Yep. And so if you say, because it goes up in 5s, then you need to say more, which you did, because this one starts from 2. It's not the 5 times table, so it starts from 2, or it could start from 1. And if it started from 1, then it would eventually reach it. So what would you give yourself for those number sequences? X a half or tick?
I'd give it. I need improvement on that.
Okay, so maybe a half. Okay, so we saw this thing before. Any idea how we do this?
Would it be just 2n plus 1, 2n plus 2, 2n plus 3, or?
So going up in the sequence, n, the first term n is 1, second term n is 2, third term n is 3. So when n is 1, what is 2n plus 1?
Um, so say that again.
So it's basically when n is 1, the first term is 2 times 1 plus 1. So what is 2 times 1 plus 1?
3.
Okay, how could you get second term?
2 times 2 plus 1.
Brilliant. What is that?
5.
Yeah. And third term.
2 times 3 plus 1.
Mm-hmm.
That'd be 7.
That's it. So the first three terms are 3, 5, and 7. And you'll notice that they're going up in 2s each time. And that's because this is 2n. So it's like the 2 times table, except each number is 1 bigger. So instead of 2, 4, 6, it's 3, 5, 7. Okay, this one down here, part B.
For 3. Wait, what's that? 3, 5, 7?
3, 5, 7 is the answer for above. So now,
okay.
part B.
What time sequence? 20 take away 5 then. Would that be 20 take away 5 times 10?
Yeah.
150.
How did you get that? Oh, Bidmas.
No, I just took 5 away from 20 and put a 0 on the end of the answer.
Bidmas.
Have you heard of
it? What comes first, subtracting or multiplying?
So say that again, subtract or multiply?
Yeah. Bidmas, which one comes first, subtracting or multiplying?
Multiplying.
Yep. So you have to multiply the two numbers first.
Times 10, 200. Is it 2 times 10 or?
No. So instead of doing 20 minus 5 first, you have to do 5 times 10 first.
Oh, okay. 5 times 50.
Yeah. And then you do the rest.
30.
50 minus 20 is 30. 20 minus 50?
Minus 30.
Correct. That's it. So you sub it in and follow Bidmas. Any questions there?
No.
That's it. Okay. Quadratic sequence 1. Let's try this.
Would it be 2 times 3 squared to take away 4?
Yeah.
3 squared is 4. No. It's 9.
Well done.
Times 9 is 80.
Uh-huh.
14.
Brilliant. Got it. You use Bidmas. And the one down the bottom doesn't look any more challenging. I think you'll be fine for that. Okay, how would we do this?
Um, how would we do this?
Hmm.
Sequence A is 3n. Sequence A. There's only one number. That is both sequence. This is confusing me.
I think the easiest way to do it. So basically, you've got two sequences of numbers, and they say there's only one number that's in both sequences. I think you should probably just write out maybe the first 5 terms from both sequences and see if they have only one number in common. So how would you do the first 5 terms for the first sequence?
3 times. What was it? The third sequence.
Let's say the first 5 terms for the first sequence.
3 times 5, 2, 3, 2, 15, 13.
Okay, so that'd be the 5th term. What would be like the first term, second term, third term?
First term, that would be 1.
Yeah, go on.
D1. And it would be 4.
Yeah.
Eight.
No.
No. 7.
Yeah.
10. 13.
Okay, and so on. Same thing, second sequence.
10 equals 2n. So for the first one, that would be 2 times 1. Minus 8.
10 minus 2 times 1. So 10 minus 2.
Oh, 8.
Yeah. I can give you a quick way once you have the first term. So the first one was 3n, so it's plus 3 each time.
Hmm?
The second one is minus 2n, so what would this one be each time?
So say that again.
So the first term is going up in 3's because it's 3n. So what would the second term, what would you do each time to get the next term in the second sequence?
Oh, would I add 2 onto it?
So this is minus 2. Minus 2n.
Over 2.
Yeah, that's right.
So it would be 6, 4, 2, 0, minus 2.
Yeah, and so on. Okay, Sally says there's only one number in both sequences A and B. Is she correct?
Yeah, she is.
Which one?
4.
Yeah, that's it. Okay, got it. So it just helps to write out the first few sequences. This one, did I not? Yeah, so let's say this one, this first one. What n is this? So the n sequence.
What?
So the first one up the top. You know how the previous one was 3n because it was plus 3 each time? The second one was minus 2n because it was minus 2 each time. So what n is this first one?
5n.
Yeah, so 5n is the 5 times table. So how is this different from the 5 times table?
How is it? What different?
So 5n is like 5 times 1, 5 times 2, 5 times 3, 5 times 4. So what do you have to do to the numbers in the 5 times table to get the number in this sequence?
Add 5 on for each time.
So what do you have to do, like going downways from 5 to 2, 15 to 12, 20 to 17?
Take away 5.
5 take away 5 isn't 2?
Take away 3.
Yep. And so this then is n times, so it's 5n because it's going up in 5s, and then take away 3 to get the first one. Okay, same thing, second one.
All n.
Yep. And maybe I'll give you a better method. 1 second. Maybe it comes later, does it? Doesn't seem to. At least I have it. Basically, what number? So for the first one, what number would come before 2? So they're going up by 5 each time, and so from right to left they're going down by 5 each time. So what number would come before 2 if you had a term 0?
What number would come before 2?
Yeah.
1.
No. So from right to left it's minus 5 each time.
It's plus 5 each time.
So from left so from left to right it's plus 5. And so what if you went backwards and you found the term before 2? If there was a term before 2, what would that term be?
So they say that it's worth it. That way it's minus 5. That way it's plus 5. What am I searching for again?
So the term before number 2 in question 1.
Minus 3.
Yeah. And so that would be minus 3, and that's where this minus 3 comes from. And so in general, the nth term, you know the equation of a straight line, y equals mx plus c. This one is like dn plus c, where d is the difference each time, and c is term 0. So same thing, part A, the difference was 4, so it's 4n, and then what would be term 0?
Minus 4. Oh, term 0, sorry. 4.
So you'd be doing minus 4 to the first term. And so what number would come before 6 if there was a number there?
Wouldn't it be 4?
That would be if they were going up by 2 each time. These are going up by 4 each time.
What one are we doing?
Middle one. Part A.
It goes up by 4 each time.
Right. So,
And
so what number would come before 6?
Six. Two.
Yeah,
Two.
yeah.
I got it. Yeah, it's right about that.
Oh, that's all right. So it's going up in fours, so it's 4n, and term 0 is 2, so it'd be plus 2. And the last one, nth term for that sequence.
Seven.
So 7n.
Yeah, 7n. 7n plus, or 7n minus 4.
Well done. Brilliant. Got it. So in general, the difference is term 2 take away term 1, or any term take away the previous one. And C is term 1 take away the difference. So basically, term 0. Yeah, dn plus C. It's a bit like mx plus C. Any questions there?
No.
Okay. Okay, how could we do this one?
Tenth term.
And for this one, it might be easier to do part B first, before A.
The expression would be, would it be 6n
Yep.
plus 4?
Well done. And now try part A.
How do I use that to help me again?
So how are we doing them before? If it's 6n plus 4 and we want the 10th term?
So do I add 4?
Let me just
No.
we did them here. So 2n plus 1, the third term is 2 times 3 plus 1. 20 minus 5n, the 10th term is 20 minus 5 times 10. Basically, n is the pattern number, the term number.
Okay.
And so this one. Any idea how to do part A using part B?
No.
So they want the 10th term, and for the 10th term, n equals 10.
Okay. Is it 6 times 10?
Yeah,
64.
well done. That's all there is to that.
Oh.
Leave that one. I'm gonna leave that one. Let's try not this one. Let's go back to the ones that we skipped from before. Because I said that using this trickier method will make them actually easier. They're supposed to be easy, but they're not. This one. How many sticks are needed for pattern 10? How would you do that? And hang on. Even before this one. Sorry, this one. Part B. How many sticks are needed for pattern number 15? How would you do that?
Needed sign.
Sorry?
How How many dots needed for pattern 15?
Yeah, and what might help is if you make it look like the other ones. So basically, let's make it easy. So you said the first one has 7 dots, then it's 10, then it's 13, and then it's 16. How could you? Any idea how you could use that to work out pattern 15? How many dots will be in pattern 15?
Can I do 5 and double it? Would that work?
What I would do is find the nth term for this sequence of numbers.
Okay, so that would be 3n plus 4, something like that.
Yeah, 3n plus 4 exactly. And now can you use that to get pattern number 15?
$49.
Brilliant, yeah. So 3 times 15 plus 4, 49. And so, yeah, so now you can see it's not a table, it's actually the number of dots. You start with 1 times, so the pattern number is 1, times it by 3, then add 4. Times by 3, add 4, times by 3, add 4. It's a way to go to calculate the number of dots from the pattern number. Okay, so this one we said was 2n plus 1. Oh, you actually got this one using intuition. Yes, we were going to try this one. So one has 10 stars. How many triangles would it have? Any idea how we could use the table or find an nth term for this one? Or how we could do it?
Nth term for this one.
Or what's the connection between the pattern number and the number of stars in the table?
An extra one onto it.
Yep. And so a pattern with 10 stars, what pattern number will that be?
Pattern number of 10 stars.
What n will have 10 stars?
1n plus 1.
So not yet. So you're correct. That'd be the nth term for that one. But just okay. So if there are 10 stars, what n is it from the table? So that in that case you have to work backwards. You're given the stars. What pattern number is it?
Oh, you've confused me. If there's...
So if the stars were 10 in the table, what would be the pattern number above it?
9.
Yeah. So we need to find pattern number 9, number of triangles. How could you do that? Pattern 9, how many triangles are in it? Any idea how you do that?
2 after... No. Add, it goes up by 1, but so you would add 11 onto...
So what would be the nth term for the triangles?
I said it a minute ago, wouldn't it be, I think I did, wouldn't it be 1n plus
so that's
1?
That's for the stars. For the triangles?
I don't know, it keeps on going up by 1, so...
No, the triangles, the bottom one.
Yeah, I know, it goes up by... I don't know how you describe it, but it goes up, so... for number 2 it goes up by 2.
Okay.
3, it goes up by 3. Ah! I just realised the pattern now.
Mm-hmm.
2, goes to 10, goes up by 10. Would it be 20?
What would be the nth term for the triangles? So 1, 3, 5, 7, 9.
I'm honestly don't know.
What's it going up in each time?
The nth term.
Right. So for the triangles, what is it going up in?
It goes up. I know what it is, but I don't know how to describe it, and it's easy.
Like it's plus what each time? 1, 3, 5, 7, 9.
Plus the number.
Which
Plus
number?
the number.
Which number?
Go for 1, 2, 3, 4, 5, 6, 7. That's stuff.
No. Triangles. So first one has 1 triangle, second one has 3 triangles, third one has 5 triangles. Nth term. What's the nth term? And the answer should look something like dn plus c.
2
Yep.
n plus minus 1.
Yep. 2n minus 1. We want pattern 9. How many triangles are in pattern 9?
17.
That's it. That's all there is to it. And so you can use this nth term even for pictures as well. Let's do it for this one. We'll skip straight to the table. What will be the 2 blanks there?
Say that again, sorry.
So part B, fill in the blanks.
"13 and 16.
Yeah. Any idea how you can... So this is the number of lines. Any idea how you can find the number of lines in pattern 12?
Find the nth term.
Yep.
Would the nth term be 3 n plus 1?
Yeah. And we want the number of lines in pattern number 12.
37.
Brilliant. 12 plus 1, 37. And we could do the circles as well. Let's see. Pattern 50. Okay, so I better just do a recap. So I think you're good for kind of drawing the next in the pattern. The important thing is to break it down to numbers. So like all the dots, it's a bit confusing, but if you just look at it as 7, 10, 13 and 16, then it's just it's going up in threes, starting at 4, and so it's 3n plus 4. It's like 4 bigger than the 3 times table. Yeah, in general, the nth term, dn plus c, d is the difference, term 2 take away term 1, and c is term 0 if it was there. Term 1 take away d, the difference, and you have to get d first so you can get c. Yeah, how do you and if you're doing like, is this number in the sequence, sometimes it's simple and you don't have to overthink it. So every number in the sequence is odd and they have an even number, or every number in the sequence is even and they have an odd number, something like that. And so you don't have to think about, overthink it. How was that for you, Dylan?
a bit hard, but I
Good.
should.
Good, because this matches up with equation of the line y equals mx plus c quite well. So if you get good at this, then you'll be good at that as well.
Okay.
Would you like to finish this next time and then move on to equation of the line?
Yeah, please.
Okay. Any questions for me in general?
No.
Okay. Well done, Dylan. You did great. I look forward to talking to you again next week.
Thank you.
All right. Have a good week.
Uh,
Goodbye.
uh,